Hello and welcome back to another LeetCode video. Today we're looking at LeetCode 3386 button with longest push time. It's an easy problem, but I think it's quite good to use it as an interview practice problem. It's not too difficult and it would allow us to focus on the interview process rather than trying to come up with the most clever solution. And this is the entire purpose of the video, right? Prepare for interviews and practice the systematic approach to a coding problem as we would in a coding interview. So step one is going to be looking at the problem, understanding what it's about. Then we're going to check out the constraints, and typically that involves asking the interviewer what the inputs and outputs should look like. And then we're going to look at some examples to get a deeper understanding of the problem and to see if we can identify any edge cases or maybe a pattern of how to solve it. And then after that, we would propose to the interviewer a way to solve the problem. And if we can, also give a runtime and space complexity analysis before we implement a single line of code. And then we would commence and implement the solution. And finally, step through it with the mental debugger or test it with our own test cases. And yeah, hopefully everything goes smooth. So that's what you would do in an interview. And we're simulating this with this easy problem here today. Right, step one. You're given a 2D array events which represents a sequence of events where a child pushes a series of buttons on a keyboard. Each event at index I consists of an index and a time that indicates that the button at the given index was pressed at the time that is given. The array is sorted in increasing order of time. Okay, the time taken to press a button is the difference between the time between consecutive button presses. The time for the first button is simply the time at which it was pressed. Return the index of the button that took the longest time to push. If multiple buttons have the same longest time, return the button with the smallest index. Okay, so what does this all mean? Well, so it seems like we have a number of different buttons and they are identified through their index, and it indicates when the button is pressed. And when the button is pressed again, that indicates that the button press ends, I suppose. The time taken to press a button is the difference between consecutive button presses. The time for the oh, I see. So we are only pressing one button at a time, and the time difference between the previous button, between the previous button press, I guess the time could be seen as the start time, and the time between when we press the previous button to the time of when we press the current button, that is how long we press the previous button. Okay, understood. Now constraints, I would like to know, how many events are there, what's the range of the values for index and time, positive, negative, all of those good things. And LeetCode, we're given the constraints usually here on the bottom. So that simulates now the answers of the interviewer. And the interviewer tells us, well, there's at least going to be one event. And the events array always has the same structure. And the index and the time in the events array, they're also always going to be at least one or larger, so positive integer. And again, all events are sorted by time, which is nice, so that we don't have to actually sort them ourselves. Okay, now let's look at the examples. So what do we have here? So we have index 1, 2, 3, and 1. So we have 3 buttons, and 1 is the only button that is pressed twice. And we can see the different timestamps. So button 1 is pressed at time 2. Button 1 is pressed at time 2. Button 2 is pressed at time 5. So it took 5 minus 2 units. Button 3 is pressed at time 9, so it took 9 minus 5 units. Right, it's always the difference. 5 minus 2 is 3, 9 minus 5 is 4 units, and the next one is 15 minus 9, that would be 6 units. Button 1 is pressed again at 16. So the events, what is the output? 1? Why is the output 1? Return the index of the button that took the longest time to press, and that is in our case button 1, right? The one at press at the okay. Example 2, input events, we have button 10 is pressed at t equals 5, and then button 1 is pressed at t equals 7. Now that means button 1 has been pressed the longest. No, button 10 has been pressed the longest, which is 7 minus 5 units, which is 2. While we output 10. Cool. So I think I understand the problem. I think what we can do here is we just have to iterate over the entire array since it's already sorted by time, and we can iterate through it in linear time and over n time. And we just have to remember what the previous button press was and then keep track of the biggest delta between the times of consecutive button presses. And when we find a new max duration, we have to update maybe a result variable that carries the index of the button that we pressed, that was pressed for the longest time. And I think that's the whole solution. So that would be linear time and constant space. And well, I would ask now if that's okay for me to implement, and then interviewer would say yes, or maybe has some questions. Yeah, and then we'll continue to implement it. So I need two variables. I need to keep track of the max duration and the button that has the max duration up until that point. And I'm just going to use max duration and max duration index. And at the beginning, they're just going to be 0. Now, I also need to keep track of the previous button press event. I'm just going to call this previous event. And I'm just going to initialize that with 0 and 0. So this is now an index and a time that I put in here. Right. So now I just iterate over all of the events. The current event in events, right? And well, what is the duration? Well, I can compute the duration just by computing the differences between the time of my previous event and of my current event, right? So that's at the time of the current event minus the one at the previous event. And I think, oh, time is at index 1, not at index 0. So I'm to put like this 1. Now I check, if the duration, if that is larger than the max duration that I currently have, well, I need to update my duration. But I also have to remember the index of max duration, and that is basically current event 0. Index meaning the ID of the button that was pressed, right? Yes. However, max duration, you think about this. Yes, that is correct. Now, what if duration is the same as max duration? Because we have another requirement here. Return the index of the button that took the longest time to push, right? That is what we determine here. If multiple buttons have the same longest return, return the button with the smallest index. So we actually have to have another check. If if duration is equal to max duration, we need to make sure that we update our max duration index. So that's going to be that. So we're taking the minimum between our current max duration index, index meaning the ID of the button. A little bit confusing that it chose to name this index, but we have to think of ID of the press button and the button that was pressed in the current event. That's what we have to do. And otherwise, we check the max duration. And in this case, we know that we get a new unique button that we press to get the max duration event. Okay. And that is all we need. That's all we need. Next, well, we need to update our previous event, right? So that we remember what the previous event was, and we just assign it what the current event was. And then finally, all we need to do, just need to return our max duration index. So that is the entire thing. Let's just go through it with one example. So that's now, I guess, the final step where we test our own code, and you can either write a little piece of test code yourself, or you can use a code and step through the code with your mental debugger, I suppose. So here we're given two events. And we initialize our variables with 0, previous 0. And now the first event that we're going to get here is the event 10.5. So the duration is going to be 10. No, it's going to be 5. Since the difference between the previous one is, which was 0, is 5. And we're not getting the same max duration, but we're getting a new max duration here. So our max duration gets now set to 5. And the button that we pressed is 10, right? Now, next iteration of the loop. So now the event to process is the event button press 1 at time t equals 7. Now the duration is, well, it's 7 minus 5, so it's going to be 2. So it's neither matching the current maximum, nor is it exceeding the maximum, so nothing happens. And we return the max duration, which was set to 10. Yeah, so I think the code would work. So next step is I would ask the interviewer, is it okay if I run the tests now? Because you always want to ask for confirmation whether you should execute your code or not. This is to allow questions, and maybe the interviewer sees that you made a mistake, so you have to pay very close attention to what the feedback is and what you're being asked. Otherwise, you risk running into this debug error cycle where you just hit run, there's a problem, you fix it, and then you go silent and you iterate trying to fix something, and you've lost the interview, and it just looks really bad and unprofessional because you've abandoned a systematic approach, right? Cool, so the test cases pass, which is very nice and encouraging, and now I'm going to submit it to see if it passes all of the LeetCode tests. And it does, and yeah, that concludes that problem.